All right, I'm going to do a relatively quick and simple, quick and dirty drag and drop. Nothing is actually going to be dragged and dropped. I'm not actually moving any text or pictures or recordings into a buffer or a clipboard. I'm simply monitoring the motion of the mouse. It turns out it's relatively simple that way. And this example here is just a set of tiles, and I can drag and drop the contents of the tiles. Actually, when I do it, the contents will swap. That's the way I decided to handle it. But you could make anything happen you wanted once you've dragged, say, A over to O. In this case here, if you drag A to O, they swap places. The A is now up here, and the O is over there. And I've added some other things, obviously, in terms of highlighting and so forth that you can see. Now, as you just saw, when I hover over, I'm getting a red background, indicating the hovering. If I were to click the O, a standard left click, you see red. If you notice over here in the background, this is the actual terminal that's from which this is running. So when I click the O, you see that button 12 was, first of all, it was pressed, and then it was detected to be a click. It was a click. It was a standard left click. It wasn't a right click. It detects button pressing. Okay, there's a button press. I haven't released it yet. When I release it, since it was a left click, it's recorded as a standard click. I could have recorded it if it was a right click too, but I didn't bother to. If I right click, yeah, I get the right click. I forgot I put it in there. That's me right clicking. The right click doesn't result in a highlight change, but you see there's the right click. The left click is the normal button for highlighting, a normal event or normal signal for highlighting a button. I just made the button highlighting unusually garish. Instead of going from one slightly different shade of gray to another, I've gone for the more dramatic look. Okay, so you can see that. Now I'm hovering on the N, and I'm going to hold down the left button. And you can see it's detected a press. I'm still pressing button 11. They're numbered 1 through 12, with the 1 being in the upper left-hand corner. Now, as I begin to drag, you see it's detecting a drag has begun over there. It says begin drag 11. And I'm going to drag it up here, and you see when I'm hovering over something in drag mode, it goes to a yellow highlight. Now I'm going to release it, and you'll see over there it says getting the value from button 11, doing a drop a drop was being done onto button number 2. So it basically then comes up and says we're moving N, which was the letter that was down here. We're moving it from tile 11 to tile 2. So I ended up actually apparently creating a little bit of a video game here that if you wanted to arrange the things alphabetic order or something like that, I suppose you could do it. But of course it's like a Rubik's Cube. It kind of jumps around. If you want to get, I also added random things, so you can get additional random letters. The text is totally random, and it doesn't mean anything. It's whatever you put in the text is what's going to mean it. Okay, where do we begin? What I use this for, basically where it came from my player, which I'll bring up here, which is a music player, which I've been oops, don't play program. I don't know what it's going to do if it tries to play the program. I hope it hasn't screwed up the audio. Am I still getting audio? Yeah, I'm still getting audio, because it has a tendency to grab stuff. But this is where it came from, that if you wanted to move something around, you could move tiles around in this thing. And copying to the same row, it detects a copy on copy. I didn't actually put that into the other, but it wouldn't have made any difference anyway. But that's where it came from. Those are where the 12 buttons actually came from. They have other information in them, but normally when you click it, you're going to get something played. All right, get rid of that. So I slimmed it down, and I came up with this. Okay, how does it work? First of all, let's look at the Glade. Here's the Glade file. Now, the text, first of all, there's 12 buttons. You can see they're 1 through 12 down here. They're Gtk buttons. They're just ordinary buttons. There's nothing special about it. But each of these buttons, if you go over here, has custom content. The custom content in the button is a label. You see the label there? It doesn't highlight itself out, but the label is in the button. It's the constant content of the content of the button. The custom content of the button, excuse me. I wanted to go with labels because it's hard to format text in the button label. The built-in label of a button doesn't give you an awful lot of formatting options. But if you put a label in here, which we've covered in another one, you basically tell it you tell the button that you want custom content, and then you'll see the button and there'll be a tiny little grayed area, and what you do is you go over here and you click on label, and you drag the label carefully into that area, and bingo, you got a label inside the button. All right, so we've got the label. We've got the label here. But with label, I have much more control over the attributes of it in terms of the font. I'm not going to get in here because the color of the font, the size of the font, and things like that. Also, in terms of labels, you've got formatting. It's built in, whether to ellipsize. Those are the 3 dots. If the thing is too long, is it going to ellipsize at the start? I think the option is start, middle, or end. Justification, whether it centers, whether it's going to wrap at a word character or word. You get all sorts of options here. Number of lines to wrap, how many characters on a line. Then it's centered down here, horizontal and vertical. 0.5 means center. 0 means left or top. 1 means right or bottom. Depending whether you're talking horizontal or vertical. So that's so you get a lot more control over a label. There's some control, but there's very little control over the contents. The label that's in a button. Buttons do have labels, okay, but you don't get as much control. So I made them labels. As I said, you get more ability to modify the content. Anyway, you don't have to do it that way. You could have done it another way. So there they are. And they're just a series of buttons, and this guy down here is just an ordinary GTK button that you click and it'll bring up it'll issue a signal that, okay, the signal that causes me to randomize and reset the contents of the label. All right, the buttons are where all the signals are. And the signals here we've got, and I'll drag this all the way over, I'm on button number 1. First of all, there's a signal for clicked, on button 1 clicked. That's if you push down the left button on the mouse and release it. That's the standard click, okay? Under GTK widget, we have a bunch of others. Button press event. This is the signal handle that will be called if you depress the left button. I'm only dealing with the left button. You can do this with the right button too, but the left button, if you hold it down, you get that press event detected. Drag begin. Guess what that is? When you're starting to drag, when you press the button down, left button, and start dragging, this is the signal handler that's going to get it. Drag get. This is when you've released the button on top of a tile. It calls this function. It also calls this function, drag drop. They both get called simultaneously. So I'm not actually moving any text. I'm not actually moving things into clipboards or into buffers and so forth. I'm getting 2 signals, and I don't really need both of them. I only need the second one. Drag drop is what I use. But drag get is in there, just to show you it works. Excuse me, drag end is the final one, if I get them all straight here. There's a drop, there's a get, and then there's an end. And let's go back up here and see it. Okay, I'm holding down the button. It sees a press. I'm starting to move. You see it gets a begin. Now I'm going to release it. And it gets the get, the drop, and the final one down there is drag end. Okay? These 2 guys, get and drop, they occur when you release the button. They all simultaneously occur. All right. Hopefully that was not too confusing. So those are my signals. Press event, drag begin, drag data get, drag drop, and a drag end. All right, and these are appropriately saved and so forth. All right, the other thing over here is CSS. I've got a subdirectory called CSS, and there's a file in it called albumbutton.css. It came from my other thing. I didn't bother to change its name. And it's got coloring. For the color of the buttons, which you see is blue on the outside and lighter color in the center. It calls it silver. It's 10% silver, and it's 90% blue, and it's an ellipsis focused on the center. You can look these up. There's a whole bunch of them as to how to create gradients. I like gradients. Anyway, they may not be appropriate if you've got a lot of text in the button, or you would have to go to a lighter color so the text would show up. You can change the color of the text, obviously. And I've got borders around. You can see as a greenish border. I've rounded the edges, the radius. That's the edges. And so yeah, there's the button basic. There's the hover. And the when you hovering, you can see it goes to red. You can see the border color is FF0000, FF0, that meaning full red. So you can see when I hover over one of these buttons, you're going to get the red outline. And let's see, there's the outline. And there's one of these up here determines the size of the outline. I forget which one it is. Let's see, this one here is the... this is yellow, so this is the one for the drop. You see the yellow I haven't dropped it yet. I'm just moving, but that's the one that gives me the yellow. Let's finish it. Let's see what happens if you drop it on itself. Oh, I thought it would crash, but it didn't. All right, you can drop it on itself. I never checked for that, but anyway, apparently I wrote it correctly. But anyway, the yellow. This is the hovering color. Excuse me. That's the red. That's the hover. This is the drop color. And it's FF, which gives you that yellow border. There's the border. Excuse me. And the center color is also yellow. You could change the center color. The out border could be yellow, and the center color could be green or something. All right, and then there is the actual click. When I click it here and you see it goes red, here's why. Because when the button is checked, it's a ellipse with the center red and the outside portion. As long as I hold it down, you see it. So there's the click, and that's a CSS file, and it's in a subdirectory called CSS. In terms of I'll leave that up there. Let's open up another terminal here, and we'll look at a couple of other things. What's in here? There's not much. There's the player.glade. That's the name from the other thing I never bothered to change. I should have changed it to tiles.glade, but it's player.glade. Player.c is still in here, which I don't actually need. Oh, I do have tiles.glade. All right, the player.glade should be. Yeah, that's no longer relevant. I hope I haven't deleted something important. But yeah, so the tiles.glade is the actual Glade file. That was debris from when I moved it in. All right, you get a compile script. I didn't really modify it too much. It's still the compile. It's overkill. It's probably loading a lot of things I don't need in terms of libraries. But again, it was pirated from that other project. But there's the compile script. This is GPL code, so the license is open source. The resource.xml, because I'm going to load that in, is fairly simple. It's got tiles.glade, and it's got button.css, which you see is in the subdirectory CSS. So get out of there. And you see as CSS contains just that. Oh, it has some other debris down here, backup copy of something. All right, what else would I want to look at here? Oh yeah, the resource.xml, that is brought in during the compilation. And you can see it down here, this so-called compilation brings in resource XML and creates a file called resource.c. Resource.c is then incorporated into your program as a subroutine or as data declarations. And that means that all of the CSS code and any other information, including the Glade code, is embedded in your program. I did an earlier video on this, which means all you have to do is provide the resource.c, and which resource.c is actually, if you haven't seen one, not exactly easy to read. It's all, apparently, I assume that's hexadecimal. I don't know what it is. It doesn't matter. I didn't write it. I mean, I wrote the XML, but it generates that, and that's used to incorporate icons, pictures, the XML file, in this case the CSS file, and the program actually accesses it with a function. Again, we did this before. All right, so there are the basic programs, and let's look at the code. That's not the code. The code is around here somewhere. All right, we've got code. All right, here's the code. It's not too messy. There's a bunch of includes. I may have included things I don't need because, as I said, this was pirated from the other project. And there could be some things that aren't necessary. I wonder if math.h is in here. I don't think I do any cosines or anything. But all right, first of all, we got the 12 buttons. They're widgets. They're global because they're used a lot of different places. And so I need all the functions need access to them. And it's difficult passing them around. So I just made them global. There's the 12 buttons. They're numbered 1 through 12. And the buttons in the Glade file were also numbered 1 through 12. Then there's the labels. They're an array of 12, numbered 0 through 12. Arrays are always start at 0. But the labels themselves are actually, what are the labels actually? Do we have the Glade tile here? The labels are, they go 1 through 12 as well. That'll show up in a moment when we get to the some of the numbering coming in. All right, so we've got the builder pointer, we've got the widget for the window, we've got the widget for the container, fixed one. That is the larger container. I didn't even bother to mention that because we use them on all of them here. At the top here, of course, we have window. There's a window which has no special attributes really or signals. We got a destroy signal. And it's got a title, which is called tiles. And then we've got fixed. And fixed is the container which holds the buttons. And one of these actually has a size numbering down here. Width and height requests are down here. But anyway, so the fixed and window are there. There's an extra widget that I'm using for temporary storage. It'll be the pointer to the label that is the target. There's a function called onWindowDestroy. So when you destroy the window by clicking the X or whatever it is on your screen in the upper right-hand box, this function will get called. There's a Gtk window, which I don't believe I actually used. It was in here. It turns out I didn't use it, I don't believe. Let's see. We've got some integers, drag source, drag target. We've got some text, which will be the text I extract or place into the label. These are temporary buffers. These are all global, of course. And we have a Gtk CSS provider, whose name, which is a pointer, and its name is CSS provider button. That will be used to attach the CSS code to the buttons. It does it. Here is the function that paints CSS onto a button. It's relatively simple. I've used it before, but it basically receives a provider and it receives a item to paint it on. In this case, it's called a widget, but it actually will be a label or a button. And it's a button actually, and it paints the CSS onto the button, and everything's fine. It's a function. You'll see me call it. There's the intro. There's some temp. I use it for something or other. There's where we initialize GTK, and we pass down to it the arguments that were passed to the function in case there was something you can pass stuff into GTK, which will affect how GTK works. I don't think I've ever actually done it. We pull out GTK Builder new from resource. That pulls it out of what was the XML file, but became the resource.c file. And that pulls out Builder out of it. And so I didn't have to read it in from a file. I get it from, it's actually part of the program. So anyway, and then I create the window pointer, or the window object from Builder, Gtk Builder, get object, and the object I'm getting is window main. That was the name of the window in the Glade arrangement up here. We've covered those before. You see the actual name of it here is window main, and the name of fixed one is fixed one, and these guys have names which are fairly obvious. So I'm actually creating the window widget by asking Gtk Builder, what do you got called window_main, and it returns a pointer to a properly constructed widget for the window. Then I say, okay, connect all the signals. Build a table that has all the signals and who they have to go to, and that way when a signal comes in, it'll know which function to go to and so forth, and it's kind of dynamic linking. You don't have to, these signals are dynamically linked into your program, or the calls are dynamically linked at this point. All right, let's see, connect, oh yeah, if you get the destroy signal from the window, call window main on window main destroy. So if you get the destroy signal, okay, on the window, which is, of course, this widget. If you get the destroy signal, then the callback is that guy. So that's not part of the ones up there that were connected. So if you want to do something special on exit, in actual fact, I don't do anything. It's meaningless. Okay, here we start getting the individual buttons. Randomize is the name of the widget pointer, and it pulls out the widget, the fully constructed widget called Randomize, and knows where to put it. It knows it's a button. It knows all that stuff. So Randomize gets it. Then we get the 12 buttons. We were going to have 7 dwarfs, but we ended up with 12 buttons. And then we have the labels 0 through 11. Labels, I could have started at 1 and just ignored label 0, but I didn't. Who would want to waste a pointer? Anyway, so the label 0 is actually label 1 on the thing. Yeah, I know I should have started everything off with 0, but I didn't. It was bad choice. I should have started off with P0 and P1 and P2 and so forth up through P11. And likewise for the labels. The labels are pointers in an array, but the buttons, they're the P1 through P12. They're not an array. There's things I can do with the array to make things more efficient, so I don't have to have 12 separate instances of everything. I can only have 1, but you can't do that with the pointers. The pointers, you're just going to have multiple callback routines. You could try to get around it by having a single callback routine for all the pointers, but then you'd have to poll to see which one you got, whether you got 0, 1, 2, 3. So it's not. Don't worry about it. There's where I pull out the container, which actually holds everything, which is a subcontainer of window, and or window main as it's actually called. The pointer is called window, and we get so we get that ready. All right, there's the alphabetic codes. You can put anything you want. That's where I create my random data from. I initialize the random number generator. Otherwise, you're going to get the same letters every time you start it. Let's see, and here's where I populate the labels. I go from 0 to 12, or 0 to 11, excuse me, from I equals 0 up through, but not including 12, so no, 0 through 11. And I extract from that array codes, I extract the element 0 through, I guess it's 25, actually. Rand returns me a number, and I mod it 26, which means the value of this expression is going to be between 0 and 25. That value selects a code from that array of letters. All right? So rand, it's a function call, modulo 26. I probably should put a blank in there to make it look a little more professional. But all right, so modulo 26 is going to be reduce the random value to 0 to 25, and that selects a code, and that prints it into temp. So printing, it actually makes it a string. So in other words, it's going to be a letter followed by a null. And then label set, that sets the label. Which label is set? Sets label I. What does it set it to? Temp. So that's how the labels initially get their characters. Or they could get strings. Okay, they could get anything you want to put. That I just use individual characters, just pure example. But yeah, that is the function that sets the text, and the text will appear in the label based on the choices you made for the attributes of the text back in Glade. Go over to Glade again, go to a label, and you see there's the attributes, where I can set font, style, all sorts of things, background color. I'm not going to play with them because I'll make a mess. But yeah, so whatever the font, whatever the styling has been set up for the label will be obeyed in terms of placing the text into the label. Okay, here's where I get the CSS stuff. We are declaring, CSS provider button's already been declared. We are initializing it by calling the function CSS provider new. That returns a pointer to a structure which is as of yet unpopulated. But CSS button is not just pointing off to infinity or something. It's now pointing at an actual populatable structure. And then I populate the structure by saying load CSS provider from And there is the thing in the, again, a load from resource, which means it's going to load from from resource.xml or resource.c actually. And it's going to find the album.css code in there. It's going to bring it in, it's going to parse it, it's going to put it into the CSS provider button. So a CSS provider button now has the information from that CSS file. Then I just paint it on all the buttons 12 times. Okay, same provider, each button. So they all get that set of attributes. Show the window, always a good idea if you want to see something, is to tell it to show the window. Let's see, background color, GTK color, and it uses a 4-digit hexadecimal number. And this would be grayish but slightly bluish. This is my background. If you notice, the background on the window is slightly slate blue or something like that, I think they call it. Anyway, modify background of window, modify BG, window, and normal. I don't know what the other codes are. There's some other codes, but normal is the one that you probably want. And you pass the address of the structure. You pass the address, ampersand, of the structure, and it modifies the background. Oh, I did pull out the GTK window. I don't actually think I use it, do I? I don't know. But anyway, I got it. That's the GTK. That's the desktop version of your program. It gets the desktop address. It is used for some things. I'm back to doing a show all. Let's see. Already shown the window. Now I'm showing all, which would include the window. All right. We're going to set up we're going to tell the system that we can drag and drop. Otherwise, it's not going to really be too happy about us playing games with drag and drop and so forth. So what we've got to do is this target here. This is a target structure. You can have an array. You have to have an array of targets. It says you can put null down, but it doesn't work. I tried null and I kept getting crashes. So I'm creating an array of 1. And it's got 3 parts, and you see this in the structure here has got the address of the target. So in this case, it's a string dummy. It's got flags, same app, which means that the dragging and dropping is occurring in the same app as opposed to other apps, inter-app dragging. There's several options there, and info, which is the number of elements in the structure, as I recall. Okay, so this is dummy. This is where you'd put things like what kind of image file it is, what type of audio file it is. It would be a MIME type. But I'm not doing that. I'm not actually dragging and dropping anything. That's just a dummy. I had to put it in. I had to put a target in. You'll see in a moment. But I left. So I just gave it one, even though it doesn't do anything. There's some other information here. Gtk Button Mask means the left button. Button 1 is the left button. Gtk Destination Default All means all options. I didn't use it, but you can see a bunch of options are strung out. You could have used GTK Destination or GTK Destination Default All. There's GDK, D is in dog, and GTK, T is in top. And obviously you can miss them up. Being lazy and not wanting to write the same thing 12 times, I wrote a macro. So I define a macro called pButtonDragSetup. Number, NBR, that's going to be the parameter into the macro. That tells me, and what I do, stand back, the GTK drag source set is telling us that this button, or is telling the system this button can be used as a source to drag. All right, what's the button? The button starts off with the letter P, and concatenated. I didn't write this. This is C's macro preprocessor. It's hideous. Concatenated with whatever the value of number is. So what the system is what C is ultimately going to see is it's going to see P followed by a number, an actual number, 1 through 12. Okay, you see them down here is where I actually call them. I pass 1, I pass 2, I pass 3. So NBR is going to be a number, and that number is going to be concatenated onto the P. This is the way you have to write it. It's not easy to read their documentation. I don't think they knew what they were doing when they were writing it, but that works. There's other weird stuff where you sometimes have to put the double pound sign on this side as well. But I don't think I ran into that. Oh yeah, I did. I see it's down there on define button clicked. Yeah, but since since the thing on the right is a special character, comma, it allows me just to have the single concatenation here. But that's what it means. It's concatenating number onto P, and there will be no blank or no pound signs when it's done. And Gtk Button Mask, button 1 mask means we're saying for the left button. This is the left button will be used for dragging. We have to pass this targs down. It likes targs. If you put, it says you can put null, but it didn't work for me. But I put one in there. It wanted one. Give it one. That's the actual number of elements in targets, I believe. And the option we're setting up is to be able to copy from one place to another with the drag. Although technically I'm not really copying. I'm cheating. This makes it easier. All right, here's the destination side. Same game with the button. You notice the backslash here means this is all one line. Backslash means the line is continued. I could have made this one long line, but it would have been impossible to read. So the backslash means it's continued on the next line. It basically it escapes the new line character, which is immediately. There's nothing after the backslash, by the way. What's after the backslash is the new line character in the actual text file, and the backslash is quoting that out or escaping that out. So the preprocessor actually sees one long line. It doesn't see the line feed. That's what's going on. So you have to have the backslash. So this is the second line of the macro. It calls another function called drag destination set. Same idea as before. And here's all these options that you can drop, you can highlight it, and you can detect motion. Okay? Or I could have said Gtk destination default all up above. And you're going to see there's ORs in between, which means I'm ORing these flags together. And I got another backslash here because I ran out of space. Convenient space. And then the final line here, he wants the targs, give it the targs, tell if you got one of them, it's not going to use them. Apparently, as far as I can tell, it's not doing anything with them. And the Gtk action copy, which means that we're allowing copy to take place. All right, and here's where we set it. Here's where we set them up. We got 12 buttons. So basically, it generates these three lines 12 times. It's easier than having putting the text in there 12 times because if you decide to modify, you only have to modify it in one place. It replicates it. So this is actually these three lines here actually each one of these things. Notice there's no semicolon at the end of the macro invocation. Each one of these generates 3 lines of code. Okay, then we kick off Gtk main. The main loop is running, and we're going to sit there waiting for interrupts or for signals. There's my window destroy. I don't do anything except call standard quick. I did everything with macros. Okay, button clicked. These are going to handle the things where, for the signal, where you just plain click a button. Standard left click. All right. And you notice here again, number is the number of the button, which will be 1 through 12, as you can see a few lines below. And you can see the double pound sign here, the blank, you have to have the blank, the actual value provided in the macro. Now you notice I got another double pound sign. That's because this guy is not considered, the underscore character is not considered a special character, so you're doing a full concatenation on the other side. It's an ordinary character in a text name. So it looks like, in reality, it's going to say on, say, P3 underscore clicked. And all I do, notice the end line character there, the continuation character, or backslash. I just print out clicked. You saw the clicks were coming up there, and I say which one got clicked. It doesn't do anything. If you wanted to do something, this is the place you would do it. If you wanted to just handle a click, put it here. And, of course, you know which button you're getting if you want to do something different for different buttons. But, again, you'd have to use this clever concatenation technique when you're dealing with it. But, anyway, number itself, as a simple macro symbol, if it's surrounded by special characters, it doesn't need the pound sign because you're not concatenating. You're just inserting it at the normal defined symbol. All right, now we get into a big macro. This is all one big giant macro here. But it's got several functions. Because these are all the drag drop functions. here is, again, we got the concatenation stuff on every one of these, so I won't discuss it again. This is the drag begin signal. And we get the widget, which is the source. We get a drag context, which I don't use, as it turns out, but there's information in there. I have not played with it. Anyway, drag has begun. So this is where you get the printout. It says drag has begun, and I remember who we started with. So drag source is an integer, and I put into drag source the number of the button that's being that we started the drag on. I'll need that later. You could do other things in here, but all I'm doing is just remembering what button you started the drag with. Okay, and again we've got okay. You see a comment in here? Drag has begun. You notice I'm using the /*//. I don't use double slash at the start because it'll eat the new line character, and you'll get a whole series of error messages because the macro is broken. So if you're going to put comments in one of these macros, use the /*//. If you forget to use it, and you probably will, you'll see a whole page of error messages. That's what happened. Anyway, believe me, I've done it. I just kind of put a blank line in here. It doesn't care. Okay, here's what happens when we get the drag drop signal, and the drag is ended. The button has been released. Button will contain the number of the target button. Okay, so we print out. See over there, it's printing out drop. Let's bring up this guy again, and is it still up here? It must be still up here. Yeah, there it is. So let me move this over, and so I take the Z. I'm holding the button down, as you can see, and I'm moving it over here. The drag has begun, and it saw me starting at number 2. I'm releasing, and now this one here is the drag drop. Drag drop says 1. So the number a drag drop gets is 1. Okay? So in other words, this guy here it saw the 1. That's a 1. That was the target, as you recall. That was I moved it from the second to the first. All right. I record that number from 1 to 12. And it's going to be the button number, so it's going to be 1 to 12 as the drag target. And I also get the address of the label. Now the label in button 1, is label 0. Okay, it's label 0. They have labels are 0 through 12, 0 through 11. So when I extract out the pointer to the label, I'll need this later because I'm going to modify the text. It's easier just to grab it right now. These are global variables. So it's number -1. So button 1 has label 0. And I get the pointer. The target label is a utility pointer. Okay, drag data get. It just happens. I don't do anything. You saw it, it popped up there. It was actually the last signal to come up. That is in the fact when you're actually physically moving, videos or something is when I guess you're supposed to start, chugging around. I don't know. Anyway, I just printed out to show you it does happen. I don't do anything. Drag end. This is where we get the move line, the very last line. The move line comes from here, and it's got the concatenation, it's got the drag context. Okay, last function called, we extract stuff. Okay, first of all, we copy into target text the contents of the label pointed to by target label, and we got target label up here. Okay, we got target label up there, so target label is a pointer to a label, and this function GTK label get text actually gets the text from the label, and I copy it into a plain old ordinary character string. Then I get the text of the label of the source, and the number we get when we're in this function here, the value of number is not the target, it's the source. So number 1 here is the these are backwards. Source text target right? The target label up here. I don't want to start this video again. Okay, the target label here is the label that we're going to, and we pull out the target label here. Okay, we get the text here, and now I may have missed my source text. Excuse me, I misread where I was, and I'm not going to start this video again. We get the label. We get the contents of the label, And the label in question is LBL number -1. Okay, number in this context is the guy that we originated. Okay, so when I'm talking that, if I'm okay, that's the origination, and I move it over here, and you can see move from 2 to 1, and when you see the text down here, move from 2 to 1, so it's the second thing here. It's the I actually extract the number. Apparently, the number was extracted up above, but it is NBR1 -1. It's the drag target. Where did drag target? I remembered it up here someplace. Where did I record drag target? Yeah, there it is right there. I recorded drag target, but drag target actually is NBR -1 at this point. Could be either way. So I use drag target, but I could have put NBR -1 in there. And the text here is the source text, is what I'm dragging, which is the letter L, and so I've got the quotes around it, /quote, and so forth. Anyway, that tells me what I'm doing. I'm moving from 2 to 1. Then I actually exchange the contents. I set the label of the target to the source text, which I extracted up above, and I set the label of the source to what was the target, so I swapped them. That's why I pulled them both out up here. Didn't have to pull them both, but I guess I could have done it in a little less effort, but nonetheless, that's where they actually get swapped, and I zero out the source and target integers. And then I create 12 copies of all that. But that's where all the work takes place. This is where the dragging and dropping takes place. All right? And this get's kind of meaningless. You don't have to have it. You can ignore the signal. The begin up here does record the source, but it doesn't matter. Down here in the drag end, the number would have been, it's the end of the drag that began at so-and-so, so the number is going to be the same. But anyway, you get that information. Okay, there's a couple other things. Button press event. On button press event, again, we get this concatenation bit. That is the hold down the button. And it gives you the button, it gives you the event, it gives you, I didn't use the user data, it wasn't necessary. And I write out button press event, and I tell you what button's been pressed, which is NBR. Then I look, the event that came down tells me, what's going on, and to the control mask. If, for example, I actually didn't do this before. Let's bring this guy up here. Okay, now I'm hovering over. I'm now holding down the left control button. Now I'm hitting the left button. You can see over on the left-hand side it says Control key pressed. Okay, now I release it. If I just normally hit it, you would have said simply click. Doesn't see Control key or anything like that. So if you want to detect, the point I put this in here for, if you want to detect other things being held down, if they're doing stuff while holding down the shift, or if they're holding down the control, if they're holding down alt, you can do it. I don't use it, okay, but it can be detected. This one here is if it's a simple left, if you do a press and release it, if it's a press event and a release, I'm not handling it any further. I say, go back to GTK, finish processing this someplace else. The false means we will continue to process this interrupt. Okay. So the fact I've pressed it shows it's a press. When I release it, it decides whether it was a simple left click, and we say return false, which means that the system will continue processing this click event. It isn't finished yet. It's just an ordinary left click. So if I just do an ordinary left click, you see the button press and you see the click 2 down there below. By returning false, it means we're not done processing. What do we do process is the simple click event. Where is that? That was all the way up the top here. We did that at the beginning. On button, on P clicked, we come down, just say click. So what you saw down here is a simple click on the left button, returned false, and that allowed it to go up here and call this function because it wasn't done. The false means we're not done. If anybody else wants to handle it, let them have it. If I return true, it means don't let anybody have it. We're finished processing this event. Nobody else needs to process it. Okay, if it wasn't an ordinary left button click, say if it wasn't a left button click, it was I'm assuming it's a right button click. Buttons do have three. Mice do have 3 buttons, but I just assumed the other one was a right click. I write out right click and hit true. I could have detected whether it was a center button or the scroll button, the scroll wheel button. You can push that in most of them. And I return true, which means no further processing. So we go back over here, and you see if I simple click, it says button press. And here we go. But 3 button press, and then we see the click thing. If I right click, it shows it there. Now they all look the same because they're all in sync. But let me click it over here. You can see you get the button press and you get the right click. All right, so it is detecting the right click. You're seeing first of all the press, and then you're seeing the click. All right, I just put some extra blank lines in there so everything didn't look like it was staggered. And finally down here is the randomize. It's just an ordinary button. It does the same thing as at the beginning, and it creates new random content. It's may sound complicated. It's only 266 lines, but it's actually fairly easy. I can think of a lot of applications you could use something like this for. It doesn't actually dragging and dropping content like files and so forth is. I'll do a video on that, but it's more complicated. So I could envision something like come up something trivial. You had a bunch of buttons that recorded the temperature, the humidity, something or other, wind velocity. And one of the buttons up here might give you the temperature. This might give you the humidity. This might be the velocity. And you have something over here, warning. So if I drag this over to here, that would say, here comes the temperature. And it says, okay, temperature is 90 degrees, but paint it yellow, indicating it's getting a little warm. If we drag the humidity over there, the dew point, and the dew point's 75, well, it says 90 degrees. This thing would record the fact that it's seen 90. And we drag a dew point of 75, it says, wait a minute, now we've got a heat index of over 100, so we'll paint it yellow. But then if I drag in the wind, 50 miles an hour from the north, well, high wind, even with a high humidity and so forth, maybe I'll just drop it back to yellow again. So in other words, things over here could be dragged into a button. That button could interpret what it's received and do something else. For example, just change colors to indicate warning levels or something like that. These could be values, and I could drag them into a button, and the button could add them up. And I could clear it and try other combinations if I'm trying to figure out a combination of things which gets up to but doesn't exceed. Or, of course, I could actually make a calculator out of this pretty easily. But the drag and drop is, and again, it seems to have ended up being something like a video game, but that wasn't the intent. They don't have to swap, of course, and they could reorganize laterally and all sorts of things, which would have meant, so if I dragged the I up here, it wasn't be a swap. It would have meant that the I moved up here, and what was in the I, which was the L, moved here, and the W moved here, and that V moved here, and that V moved here, and the K moved here. Anything was possible. I didn't want to get into the extra effort, but it just strikes me as a keyboard, as a thing like this. It's got a lot of potential application. It's really not all that difficult to do. All right, I don't know how long I've talked, but I think I should stop.